In this video, we're going to look at an example of a power series that converges at one endpoint of its interval of convergence, but not the other. So in this example, we've got the series from 1 to infinity of x to the n over n 3 to the n. We could use either the ratio or the root test in this case to get at the answer. We'll use the ratio test in this example. So remember, your ratio test does the limit as n goes to infinity of the absolute value of the ratio of consecutive terms. So let's put the pieces together that match. First here, this 3 to the n would go on top. We have 3 to the n over 3 to the n plus 1. When we simplify, that just becomes 1/3, and we can certainly pull that outside the absolute value bar. Here again, this n will flip to the top. So we'll have n over n plus 1. The n's here are all positive, so we can pull those also out in front of the absolute value sign. X to the n plus 1 over x to the n. We'll simplify it as just an x. Absolute value does matter on those, so we get absolute value of x there. As n goes to infinity, n over n plus 1 goes to 1, so this limit turns out to be 1/3 absolute value of x. According to the ratio test, in order to converge, this limit needs to be less than 1. So we need 1/3 times the absolute value of x to be less than 1. Solving for the absolute value there, we get absolute value of x is less than 3. That now fits our appropriate form for determining what the radius of convergence is, so it must be 3 in this case. The center of this power series is 0. Since the radius of convergence is 3, the endpoints are -3 and 3 for our interval of convergence. When we put in -3 for x, we get -3 to the n over 3 to the n. That will simplify to -1 to the n over n. This is the alternating harmonic series. In particular, 1 over n is a decreasing sequence and it has a limit of 0. So the alternating series test tells us that this particular series converges. However, when x is equal to 3, we do get just the harmonic series, no alternating piece here, and we've seen before that the harmonic series diverges. So this particular series converges at the left endpoint and diverges at the right endpoint, so we get the half open interval -3 closed to 3 open for our interval of convergence.